We're going to look at quadratic word problems, specifically consecutive integers. Now, what a consecutive integer is like 1, 2, 3, 4, 10, 11, 12, 13, numbers that go in a specific order. And we can have consecutive integers, consecutive even, or consecutive odd. So we're used to seeing consecutive integers like 1, 2, 3, 4, etc., etc., etc. However, in math, we could also, specifically algebra, if we don't know what things are, our first number could be x. The one after that, we would have to add 1 to it, so x plus 1. And then the next number would be 2 would be added to our original number, because 1 plus 1 gives me 2, 1 plus 2 would give me 3, 1 plus 3 would give me 4. So we're going to use that formula, that sequence, to get unknowns. So if we know the numbers like 1, 2, 3, 4 versus unknowns x, x plus 1, x plus 2, x plus 3. Consecutive even integers, obviously even numbers are numbers that are divisible by 2. So 2, 4, 6, 8, etc. Now, if we follow the same logic, our unknowns, our first number is going to be x. So let's say our first number was 2, what do I have to add to 2 in order to get 4? Well, in this case, we would have to add 2. And then again, 2 plus what would give me 6, so x plus 4. And then it would be x plus 6, on and on, following that pattern. Consecutive odd integers. Odd integers are numbers that are not divisible by 2, so 1, 3, 5, 7, etc., etc. And if you look at the pattern, our first unknown would be x, and then I would have to add 2, then I would have to add 4 and 6. So consecutive even and consecutive odd integers follow the same pattern if we don't know what they are. So x, x plus 1, x plus 2, x plus 3. If they are consecutive integers, x, x plus 2, x plus 4, x plus 6. If they are odd or even integers. So let's take a look at how that looks within problems, word problems here. So here we have to find two consecutive odd integers whose product is 99. So consecutive odd integers, they don't tell us what they are. So the first one is our unknown x. So we'll say x is our first number, whatever it happens to be. Now the next number has to be odd. So if I take a look at my nice little pattern up here, my second number would be x plus 2. So that's going to be my second number. So there's our two consecutive odd integers. So we got that part taken down. And we know they tell us the product is 99. So product tells me I have to multiply these two numbers. So this would mean I have to take x and I have to multiply times x plus 2, and I get 99. So what I'm going to do is I am going to multiply x times x plus 2. So x times x gives me x squared, x times 2 gives me plus 2x, and that gives me 99. Now at this point, I still don't know anything. However, if I think about what I did yesterday in terms of factoring, I do know if I have a quadratic equation equal to 0, I can attempt to factor and come up with numbers that make sense. So x squared plus 2x, so I have to get this equal to 0, so I'm going to subtract 99. So I can't take 99 away from x squared or 2x, so we have x squared plus 2x minus 99 equals 0. So there's the quadratic equation. It's in standard form. It's equal to 0. So now we can use factoring in order to come up with the numbers. So here, x squared plus 2x minus 99 is 0. Well, I know when I factor, I come up with two sets of parentheses. First times first is going to give me x squared. So x times x gives me x squared. And 99, my numbers that I come up with have to multiply to 99 and add to positive 2. So I got to come up with numbers that will multiply to 99, which, if I think about it, is 99 times 1, 33 times 3, and 11 times 9. So out of these three pairings, again, my equation has to equal 0. So out of these three pairings, which of these three will get me to 2 by adding? 99 plus 1 gives me 100. 99 minus 1 is 98. 33 plus 3 is 36. 33 minus 3 is 30. 11 plus 9 gives me 20. 11 minus 9 gives me 2. So that is what I want. I want 11 and 9. So what I do now is I will have to figure out which number gets a sign, because it multiplies to a negative. The only way I get a negative with multiplication is by multiplying a positive times a negative. And again, the trick is the middle term, whatever sign is on the middle term, the larger of the two numbers gets it. So if I look at 11 and 9, the larger of the two will get the plus. So 11 being larger is plus 9. So now what I need to do is I need to separate them. I'm going to get into a t-chart and set each equal to 0. So x plus 11 gives me 0, and x minus 9 gives me 0. And I'll solve for x. So minus 11, so we get x equals negative 11. And then if I take a look at this one, I have to add 9 to both sides, so I get x equals 9. This should be negative 11. So now we have a couple options. I have x equals negative 11 and x equals 9. So first thing I need to do is make sure that the consecutive odd numbers multiplies to 99. So if x is negative 11, that means x plus 2, so negative 11 plus 2 gives me negative 9. So those are two consecutive odd integers. So negative 11 times negative 9. So negative 11 times negative 9 gives me positive 99. So we're good there. So negative 11 and negative 9. And then x is 9. So if I add 2x plus 2, 9 plus 2 gives me 11. So 9 times 11 gives me 99 as well. So those are actually two possible scenarios in which I have two consecutive odd integers whose product is 99. So we actually have two answers. Negative 11 and negative 9, and 9 and 11. Both work. Both are answers because they satisfy the terms. Two consecutive odd integers whose product is 99. Now, number 2 says a certain number is added to its square is 30, and we got to find that number. So a certain number, it doesn't tell us what the number is, so that will be our unknown. So we can say x is the number. Now it says the number added to its square, so x's square is just x squared, is 30, and we have to find the number. So here we don't have a lot to go on. Number 1, it's kind of convoluted and jumbled up. So what we have to do is make sure it's in standard form and equal to 0. So first of all, let's make it equal to 0. So we subtract 30 from both sides. So we end up with equaling 0. Now, I cannot subtract 30 from x or x squared. So x squared, because I want it in standard form. So x squared being the higher exponent comes first, and then plus x minus 30. So what I need to do now is I need to find the value of x that satisfies this thing. So I need to factor x squared plus x minus 30. So once again, if I factor it, I'm going to come up with two sets of parentheses. And it equals 0. So how do I get, first guy in each parenthesis will multiply to x squared. So how do I get x squared? Well, the only way is x times x. The next step is to come up with the two numbers. The two numbers, again, must multiply to 30, our last number, and they have to add to positive 1 in this case. So 30 is 30 times 1, 15 times 2, 10 times 3, or 6 times 5. Now going down the line, the only one that would possibly get me 1 is going to be 6 and 5, because 30 and 1 will make 31. If I subtract, I'm not at 1. 15 plus 2 gives me 17. 15 minus 2 gives me 13. 10 plus 3 is 13. 10 minus 3 is 7. 6 plus 5 is 11. 6 minus 5 gives me 1. So that's why I'm picking 6 and 5. I need it to be 1. Now again, we have a negative. It has to multiply to a negative, so that means one is plus, the other is minus. The question is which one. The bigger one in our case is going to get plus. So 6 being bigger than 5 will get plus, minus 5 equals 0. Now we make a t-chart and set each one equal to 0. So x plus 6 is 0, and x minus 5 equals 0. So if I subtract 6, I end up with x equals negative 6. And over here, I add 5, and I get x equals 5. So again, like up above, we end up with two possible answers, so we need to see if one doesn't work. So a certain number added to its square. So negative 6 plus, and then I have to square negative 6. And according to our problem, it equals 30. So negative 6 plus negative 6 squared gives me 30. So negative 6 works. We're good there. Now I'm going to try 5. So 5 plus 5 squared also gives me 30. So again, just like up above, we end up with two answers that satisfy the situation. A certain number added to its square is 30. So number 3, we have the square of a number exceeds the number by 72, and we got to find the number. So again, we don't know what the number is, so we might as well just say x equals the number. So the square of a number exceeds the number by 72. So that means whatever our number, the square of a number is larger than the number itself by 72. So if I subtract x, I'm going to get 72. Basically, this situation says when I square a number, the difference is 72. So now I need to figure out what that number is. So again, I want this to be in standard form. I need this equal to 0. So we're going to subtract 72 in order to make it equal to 0. So now we have equals 0. 72 minus 72 is 0. Now I cannot subtract 72 from x squared or x. So we're just left with x squared minus x minus 72 equals 0. Now what I can do is I can try to factor this. So again, once I factor it, I know I get two sets of parentheses equaling 0. The first guy in each one has to multiply to x, so the only way I get that is x times x. Now I got to come up with two numbers, and again, the two numbers will multiply to negative 72 and add to negative 1. So what multiplies to 72? Well, 72 times 1, 36 times 2, and then we got 24 times 3, and we got 18 times 4, 12 times 6, 8 times 9. So we have much more options here when it comes to coming up with 72 and -1. So the question becomes, how do I get -1? Well, which one of these pairs only has a difference of 1s? Well, the only one that has a difference of 1 is going to be 8 and 9. So those are the numbers we're going to use. So now, again, we multiply to a negative. So that means something is positive, something is minus. And the trick to it is whatever sign is on the middle term, the larger of the two numbers we came up with gets. So the middle term being minus, that means the larger of 8 or 9 will be minus. So 9 being larger is minus, 8 gets plus. Now we're going to split this up using a t-chart and setting each one equal to 0. So we get x plus 8 is 0, and x minus 9 gives me 0. And we're going to solve for x in both cases. So over here we have to subtract 8, which means x is -8. And over here we'll add 9, which means x gives me 9. So again, we have two possible numbers. So we have to see if the square of a number exceeds the number by 72. So first things first, -8. So here we have to basically follow what we came up with, x squared minus x. So -8 squared minus -8 is 72. So -8 being the number is feasible. It works. And then 9, I'm going to do the same thing. 9 squared minus 9. And I also get 72. So both -8 and 9 are good numbers when it comes to satisfying this problem. Number 4 is a little more wordy. 2 consecutive positive integers such that the square of the first decreased by 17 equals 4 times the second. So this one, we got a little, I suggest marking up. We got 2 consecutive positive integers. And then it tells us the square of the first decreased by 17 equals 4 times the second. So we got a whole bunch going on here. So 2 consecutive positive integers. So we don't know what the positive integers are. So x is the first positive integer. Now consecutive, there's no stipulation like even or odd, so the next one will be just one more. So x plus 1 is the second positive integer. So now we got to set up the equation here. The square of the first. So the first number is x. So that means x squared. Decreased. So that means we're going down. So we're going to subtract. In this case by 17. So 17 equals, pretty straightforward, equals 4 times the second. Again, that means 4 times the second number. So 4 times x plus 1. So now what I need to do is I need to simplify this and get this into standard form in order to be able to factor it. So x squared minus 17, I can't do anything on this side, so we're just left with x squared minus 17. I'm going to distribute the 4, so we get 4x plus 4. Now, this is not equal to 0, so I'm going to take a look at x squared. If x squared is even, I'm going to keep it on the side where it's at. If it's negative, I'll move it over. In this case, x squared is positive, so I'm not going to touch it, which means I'm actually going to move the other side. So here we have to subtract the 4x and minus 4. So we're going to subtract 4x and 4 from both sides. So 4x minus 4x goes away, we're left with 0. Same with 4 minus 4 is 0. So this side we're equal to 0. Now I cannot take 4x away from x squared or 17. So There is no x squared to combine, so x squared. There's nothing I can combine with the 4x, so minus 4x. But I can do negative 17 minus 4. So negative 17. And I get minus 21 equals 0. So there is standard form for our current trinomial. Now what I need to do is I need to find the value of x that satisfies this equation. So again, we're dealing with the trinomial x squared minus 4x minus 21 is 0. Now I want to factor it. So I have two sets of parentheses and I end up equaling 0. So again, first times first is going to give me x squared. So the only way that happens is x times x. Now what I need to do is come up with numbers that multiply to negative 21 and add to negative 4. So it's easier to list off the factors of 21. So 21, 1, 7 times 3. And that's all we have. So I need to pick the pair here that will add to negative 4 somehow. So in this case, 7 and 3 are the numbers that I'm going to be using because the difference between the two numbers is 4. Now we multiply to a negative, and the only way I get a negative is a positive times a negative. So this means one is plus and the other one is going to be minus. Question is which one? Again, middle term, whatever sign is on the middle term, the larger of the two numbers will get. So 4 is minus, so 7 is going to be minus, plus 3. And what I'm going to do is I will make a t-chart and set each of these equal to 0. So x minus 7 is 0, and x plus 3 gives me 0. And I will solve for x. So here we have to add 7 to both sides. 0 plus 7 gives me 7. On the other side, we're going to subtract 3. And we end up with x equals negative 3. Now this one actually had a stipulation. This one says I needed 2 consecutive even integers. So if I take a look at this one, x is 7. If I think about consecutive numbers, x plus 1, 7 plus 1 is going to give me 8. X plus 1 here, negative 3 plus 1 gives me negative 2. But I needed 2 consecutive positive integers. So if I take a look at this, I only have one set of positive numbers, which is going to be 7 and 8. That's the only one that will satisfy it, because if I take a look at negative 3 and negative 2, they're not positive, they're negative. So these will not work. So I can actually just cross them off because they're not going to work. So 7 and 8 are the two numbers that will be my answer in this case because of the stipulation up here that I had 2 consecutive positive integers. Now if I take a look at number 5, we have the ages of 3 family children expressed as consecutive integers. Square of the age of the youngest child is 4 more than 8 times the age of the oldest. Find the ages of the 3 children. So here we have our unknown ages. So the youngest will be x. Consecutive, so the next one will be x plus 1 is the middle child. And x plus 2 is the oldest. So here we have a comparison. So we took care of 3 family children. 3 children as consecutive integers. So we define them as x, x plus 1, x plus 2. Now we have to take a look at what is told. The square of the age of the youngest child is 4 more than 8 times the age of the oldest. So, square of the age of the youngest means x squared is equals 4 more than 8 times the age of the oldest child. So we have to do 8 times the age of the oldest. So 8 times the oldest, x plus 2, and then 4 more means we add 4. So here's the initial setup. Now what I want to do is I want to simplify this. So we have x squared equals, and we'll distribute the 8. 8x plus 16, and then plus 4. Combine like terms, so we have x squared equals 8x plus 20. Now again, we need this to equal 0 in order to be able to figure this thing out, x squared being positive, so I'm going to move the 8x and the 20 on over. So we'll subtract both of them. So I cannot subtract 8x or 20 from x squared. So we actually have x squared minus 8x minus 20 equals 0. So here is the trinomial that we need to factor. We got to factor the x squared minus 8x minus 20 is 0. So here we need 2 sets of parentheses. That's going to equal 0. So how do I get, again, the first items have to multiply to x squared. The only way is x times x. So x times x gives me x squared. Now what I need to do is I need to come up with the numbers that multiply to negative 20, but add to negative 8. So it's much easier to list off things that multiply to 20. So 20 times 1, 10 times 2, 4 times 5. So we have 3 options here where I want to see which of the 3 pairs here has a difference of 8. So 20 and 1, the difference is 19. 10 and 2, difference is 8, so that could work. 4 and 5, difference is only 1. So again, if I add 4 plus 5, I get 9. 4 minus 5 would be negative 1. So I can't get negative 8. 10 plus 2 is 12. 10 minus 2 is 8. So 10 and 2 are the numbers I'm going to be dealing with. So 10 and 2. So again, we're multiplying to a negative number here, negative 20. So that means one of those 2 numbers we came up with will be positive. The other will be minus. Positive times negative makes a negative. The middle term here is a negative, so that means my larger of the 2 numbers will be negative. So negative 10 and negative 2. So here, what we are going to do is we are going to separate into a t-chart. So we get x minus 10 equals 0, and x minus 2 equals 0. Solve for x. In this case, we'll add 10. So we get x equals 10. Over here, we're going to add 2 to both sides. So x, in our case, equals 2. So here we have 2 possible answers for our youngest child. Our youngest child could either be 10 years old or 2 years old, and we don't know which of these it could possibly be. So here we need to figure out which one actually satisfies the answer. So if I square 10 and if I plug 10 in, we can see if that works. So 10 squared gives me 100. So if I plug in 10 on the other side, 8 times 10 plus 2 plus 4 also gives me 100. So 10 works, and let's see if 2 works. So 2 squared is 4. So if I plug in 2 on the other side, so 8 times 2 plus 2 plus 4 gives me 36. So this tells me 2 is not the h. I did not get the same thing on both sides of the equal sign for our original equation. So 2 cannot be our answer, which means our youngest child is 10, the middle child is 11, and the oldest is 12. So that is using word problem. Again, it could have been 2 or 10 because age is only positive. Both were positive. So we had to test it to see which of the 2 were the correct answer. So Some scenarios, like the first three, we're going to come up with two possible answers because it's just a generic equation and problem finding two consecutive numbers. So as long as they satisfy, they're fine. 4 and 5. 4, we had a stipulation, had to be positive integer. In this fifth problem, we actually had to test which of the two answers it could possibly be. So always go back and check your work, especially when we're dealing with quadratic factoring, seeing what our possible answer is. So again, this is using consecutive integer, even and odd integers as well, in order to use factoring within quadratic expressions and equations.